In this problem, we're going to be finding the integral of 2x minus 3 times e to the 3x squared minus 9x dx. So, this is going to be another one of our u substitution problems. In general, whenever you have two functions being multiplied together, in this case 2x minus 3 and e to the 3x squared minus 9x, you're going to have a u substitution. So, we want to let u be equal to the function inside of our most complicated function. So, if you notice, e to the 3x squared minus 9x is much more complicated than 2x minus 3. So we're going to pick that as our complicated function, and we're going to let u be what is inside of that 3x squared minus 9x, of that e, which is the 3x squared minus 9x. So we'll say u equals 3x squared minus 9x, which means du, which is the derivative of u times dx, will then be 6x when we multiply our exponent out front and subtract 1 from it. And then the derivative of negative 9x will just be negative 9. So we get du is 6x minus 9 all times dx. And we want these parentheses around it because the entire thing is being multiplied by dx. From here, we need to check, do we have 6x minus 9 times dx in this problem? Well, we don't have 6x minus 9, but we do have 2x minus 3. And if we were to multiply 2x minus 3 by 3, like so, then when you distribute that 3, you would get 6x minus 9, which is exactly what we're looking for. So we're going to multiply the inside of this integral by 3. Remember, we can only do this with constants, so we can't multiply the inside of it by an x, for instance. And when we do that, we have to then multiply the reciprocal of that number to the outside, so it's as if we multiplied by 1. So 1/3 times 3 is just 1, so we haven't changed the problem. So this gives us 1/3 times the integral of 6x minus 9 times e to the 3x squared minus 9x dx. And although this next step isn't necessary, I want to do it just to show what's really happening here. I'm going to rewrite this problem. Since we are multiplying 6x minus 9, e to the 3x squared minus 9x, and dx together, then we can rearrange them in whatever order we want. You can do that because when you're only multiplying, order does not matter. For instance, 2 times 3 times 4 is the same thing as 4 times 3 times 2. So, if we go back to this integral, this is the same thing as 1/3 times the integral of e to the 3x squared minus 9x times 6x minus 9 dx. This is the same problem. All we've done is reorder our first two multiples. But now it's much easier to see that 6x minus 9 times dx is our du that we have over here. So we can substitute in du for this value. So we get 1/3 times the integral of e to the 3x squared minus 9x is now our u. So we get e to the u and 6x minus 9 dx all becomes du. From here, the integral of e to the u du is now one that we know how to do. The derivative of e to the u is the same thing as the antiderivative of e to the u. It's just e to the u. So we get 1/3 times e to the u plus c. And now we just want to go about simplifying this. 1/3 times e to the u is just e to the u over 3 plus c. And now finally, we'll substitute our value of u back in because we didn't start this problem with u. We started it with x. We need our original variable. So we get e to the 3x squared minus 9x all over 3 plus c. And that is the antiderivative of 2x minus 3 times e to the 3x squared minus 9x dx.